And the first objective, I want you to understand probability to solve simple problems involving theoretical probability. The language of chance. The likelihood or the chances of an event occurring is called probability. We use this in everyday language. You've heard it on the news many times that, for example, there's a 40% chance of rain today, or the odds of your favorite NFL team winning the Super Bowl is a 1 to 2, or that it is highly unlikely that you will win the lottery. The probability outcomes range from 1, meaning that it is 100% certain that this event will occur, to 0, meaning that it is impossible, there's a 0% chance that it will occur, to the middle ground of there being a 50-50 chance or 1/2, 50% chance that it occur. In other words, the more you move toward 1, the more likely or more certain the event will occur, versus the more you move toward 0, the less likely that the event will occur. Now, there are two types of probabilities. There's a theoretical probability, which is determined mathematically, and it describes what should happen based on the facts. And then there's the empirical probability, which is what actually occurs when repeating a probability experiment over and over and over again. So after many trials based on these experiments, we can conclude thus. So that is what you call the empirical or the experimental probability. Some basic facts you should know is that when we speak of rolling a die, we're talking about a fair die, one that has one particular number for each side. It doesn't contain anything abnormal about it. Also, experiment, when we speak of experiment, for example, if you toss a die to see which face lands up, then that's an experiment. You know, how many dots lands face up. Outcome, when we speak of outcome, that's the result of a single trial. Like when you roll a number on a die. So one roll would produce an outcome. Equally likely, when you hear that phrase, for example, in using the die as an experiment, when you roll it, each one of the sides, there are 6 sides to a die, so each one of those numbers, 1, 2, 3, 4, 5, and 6, they all have an equal chance of landing face up. And so that's what we mean by a fair die. Now, if you had a die, like sometimes magicians and so forth may have a die where it may have more than one side of the same, just to increase the likelihood of that event happening. But for all experiments in this section, we will be referring to a fair die, which means each side has the number either 1, 2, 3, 4, 5, or 6. Sample space, when we speak of sample space, it's all of the possible outcomes of an experiment. So all of the possible outcomes in terms of rolling a die would be obtaining either a 1, a 2, a 3, a 4, a 5, or a 6. Now, event, when you hear me talking about event, it's actually when you roll a number, or for example, you say rolling a 5. So the way you would refer to that is P and then in parentheses a 5. In other words, the probability of rolling a 5, that's your event. That's the thing that's happening. The event is the thing that is happening. All right, so now we're past the vocabulary. Let's get started. We're going to first start with theoretical probability. Theoretical probability. Now, theoretical probability occurs without having to do an experiment or any analysis of data. It's just simply finding the probability of something based on the math facts and based on common sense or what should occur. Now, when all the possible outcomes are equally likely, such as tossing a coin or tossing a die, then you can find the theoretical probability of that using the formula. And the formula for that, P of E, the probability of an event. E is meaning the event. The top number of your fraction is always going to be the event itself of what you want to occur. The bottom number is the total number of outcomes that you can have for that particular event. So for example, find the probability of tossing a coin that would land heads up. So the event that we want to occur here is we want heads to be up. So when we think about this fraction, the top represents the event. So the event is getting a heads. So this is definitely a theoretical probability, because if you look at the facts of it, a coin has only two sides. You're either going to flip the coin and you're going to get a heads, or you're going to get a tails. We call that the sample space, which is all the possible outcomes that could occur for that particular event. So since there's two sides to a coin, only one of those sides is a head. So that goes on top, the 1 for the heads. That's the event that I want to occur. And on bottom would be your total sample space of possible events, which is a 2. So again, 1 is for heads. That's the event that we want to occur. There's only one side that has heads. The bottom of your fraction stands for all the possible outcomes that you could have. And there's 2 possible outcomes, head or tail. So your probability of getting heads is 1/2, which you can write that another way is just saying a 50% chance or 0.5 chance that it will land heads up. And again, that's where theoretical comes from. It's just based on the facts, the math of it. You know, what should occur based on the fact that you only have 2 sides, that there's no other way other than there being a 50-50 chance of getting a heads or a tail for that matter. It doesn't matter. It's going to always be 50-50 based on the facts and based on what should occur. Now, the solution to a probability problem can be written in one of 3 ways. You can write it as a fraction, it can be written as a decimal, or it can be written as a percent. So going back to the previous problem that we were working on coins, it was written as a fraction of 1/2, but you can easily just by top divided by the bottom. If you were to do that on the calculator, what you're going to get is 0.5. If you want to turn it into a percent, remember all you have to do is move 2 places to the right and then place your percent symbol. But again, probability most commonly is written in one of the 3 ways seen here. Again, fraction, decimal, or percent. Assume the spinner to the right cannot land on the line. give the probability that the spinner would land on A, red, B, yellow, and then C, blue. So the probability of an event occurring, recall the formula for that, is the top, the numerator is the event itself that you want to occur, over the bottom, which is the total number of outcomes that could happen. So let's start with red. So on top would be the event of getting a red. So the number of red regions, we have one region that is red, so 1 is going to go on the top. As far as the bottom, the total number of outcomes, well, even though we only have 3 colors, red, yellow, and blue, there could be 4 different outcomes, meaning it could land on either of the 4 regions. So we need to include them there, each region that the spinner is capable of landing on. So then the probability of landing on a red would be a 1/4 chance of it landing on red. Now we can write that as a decimal by simply top divided by the bottom, and that's going to give us 0.25. To turn it into a percent, move 2 to the right, which means there's a 25% chance that this could land on red. And if you look at the picture of it, that's right in line with what you see. There's a quarter of it that's red, which is a quarter of something is the same as 25%. What about yellow? So first, the probability of the event being yellow on top is the event itself. So let's look at how many regions are yellow. We have 2 regions that are yellow, so a 2 goes on top. Total number of regions that the spinner could land on, 4 regions. So that's 2 out of 4. When you reduce that fraction, that's 1/2. 1/2, you change that to a decimal, top divided by the bottom, that's 0.5. Move it over 2 places for a percent, and that'll be a 50% chance. And that's right in line with what you see visually on the spinner. If you have 2 slices of the pie, that's half of the pie. Now let's find out what's the probability of landing on blue. So the top again is the event blue occurring. There's 1 region that's blue, so 1 would go on top. There's a total of 4 regions that you can possibly land on, so that's 1/4, which again is the same as 25% chance of landing on blue. Suppose the spinner shown here is spun twice in succession to determine a 2-digit number. Give each of the following. A, the sample space. The sample space, or what are all the possible outcomes? Well, since the spinner can land on any one of these 3 regions, your outcome for spinning it the first time, you can get a 1, a 2, or a 3. Now, spinning it the first time, if you get a 1, your second digit can also be a 1. Or your second digit can be a 2. So if your second digit is a 1, it's going to give you 11. If your second digit is a 2, it's going to give you a 12. If your second digit is a 3, it's going to give you 13. Now, let's spin it again the first time. What if the first time we land on a 2? If we land on a 2 the first time, the second digit can be a 1, which will give you 21. The second digit can be a 2, which will give you 22. The second digit can be a 3, which will give you 23. Okay, what if we spin this thing and the first time we get a 3? If we get a 3 the first time, the second digit could be a 1, which is going to give you 31. The second digit could be a 2, which will give you 32. The second digit can be a 3, which will give you 33. So in other words, all the possible outcome or the sample space is as follows. Okay? So the reason I went over that extensively is I wanted you to see how we came up with all those numbers. So now that we have all those numbers in our sample space in terms of the possibilities, you can get any of these numbers. Let's count these. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. So on the bottom for the total outcome, possible outcomes, you will have a 9. Now, let's do B and see what this event is. This event is the probability of getting an odd number. So what you have to do on top is you're going to be your odd number. So we look at our sample space and we go in and we get our odd numbers: 11, 13, 21, 23, 31, 33. And let's count how many that is. That's 1, 2, 3, 4, 5, 6 out of the 9 numbers are odd numbers. So our probability of getting an odd number once you reduce your fraction is 2 out of 3. So if you do top divided by the bottom, you can also get your percentage as well. But here, I just want you to be able to do the fraction of that. All right, next we have our next event. C is the probability of getting a number with repeated digits. So we look in our sample space and see how many of the digits repeated, meaning it's the same digit. So we have the 11, we have 22, and we have 33. So there were 3 out of the 9 numbers that repeated themselves. So the probability is 3 over 9. When you reduce the fraction, it's 1/3. And again, keep in mind, any of these, you can turn them into a decimal or fraction. We've already went over that process, but I just want to, this particular exercise, we're going to put them all in fraction form. Let's go to event D. Event D is the probability of a number greater than 30. So let's go up in our sample space and count all numbers greater than 30. So that would be beginning with 31, 32, and 33. So there are only 3 out of the 9 numbers. So that probability is going to be the same as the previous probability, which is 1/3 probability. Next, the probability, our last event, is of getting a prime number. And so when we look at our sample space, prime numbers are numbers that when you multiply them, or their product of their numbers is just 1 and that number itself. There are no other numbers that will produce that result. For example, 11 is a prime number. The only way you're going to get 11 is just 1 times 11. 13 is also a prime number. Okay? Not 21, because 7 times 3 is 21. So 21 is not it, even though you may think that it's odd. It's odd, but it is not a prime number. 23, however, is a prime number. And we have 31. So of that sample space, we have 4 out of the 9 numbers that are prime. So that would be 4 over 9. And there you have it, spinning a spinner to generate 2-digit numbers. In this example, we have a dice that's being rolled, a pair of dice. So you have these 2 dice that you're going to roll. Now the chart that you see below shows you all the 36 outcomes, because there are 36 outcomes that you can get by rolling 2 dice. For example, one of the dice can have a 1 and the other can have a 1. Or it can be a 1 and a 2, or 1 and 3, all of the different numbers that you have there along with 1. Or you can spin it the first time and get a 2, and the second time again a 1, 2, 3, 4, 5, or 6, and so forth. So it continues on with that same pattern for both dice. So now we are asked the question, what is the probability of getting a sum of 5? In other words, when you roll the dice and you count the dots, that it equals 5. So we can look at the chart and just look for all the outcomes that when you add them up will equal 5. And so we see here you can roll a 1 first and then a 4, that will give you 5. Rolling a 2 and then a 3, that will give you a 5. Same thing the other way around, rolling a 3 first and then a 2, that will give you 5. Or rolling a 4 first and then a 1, that will give you a 5. So if you take a look at these and notice that they are diagonal of each other, there is a 4 out of 36 probability of getting a sum of 5. And then you have to, of course, reduce your fraction. So once we reduce our fraction, it's going to be 1 over 9. Okay? Okay, so we're going to do one more theoretical probability. And as I stated before, theoretical probability is based on the math and based on the facts. Whether it's a coin that has 2 sides, or it's a dice with 6 sides, or whether it is a spinner with a certain amount of regions, or cards with a certain amount of faces. So the point is, it's all based on those facts of what you have, of what the probability of it could be. You know, it's based on what actually can happen. Okay, so in this particular one, it says one card is to be chosen at random from the deck of cards. Determine the probability that the card selected is, and then you have the 4 events. So first of all, I want to do some quick facts about a deck of cards. Well, a deck of cards have 52 cards in it. Half of the cards are black, half of the cards are red. There are 4 suits. And what they mean by suits is the cards that have the different names. You have the hearts, all of those have like red hearts on them. You have the club, that has the black symbol of the club. You have the diamonds, the red diamonds, and the black spades. So you have the hearts, clubs, diamonds, and spades are the 4 suits. And then you have 3 of the card types that are referred to as the face cards, and that's the jack, the queen, and the king. And again, they call them that because if you look at those cards, those are the only ones that have the faces of the jack, queen, and king on them. All right. So based on all that information, then let's go ahead and get started. Notice you have 4 of each of the cards that are there. So event A, what is the probability of getting an 8? Well, if we look at our deck of cards, we have 4 8s because each one of the suits has an 8 in it. So that's 4 out of the deck of 52. So when we reduce our fraction, it's 1/3. Our next event is a club. And so the club looks a lot like the 3-leaf clover. So we want to see how many clubs do we have? Well, if you notice here, there are what? 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 clubs. So you have 13 of each suit. So 13 times 4, that's how you got the 52. So 13 of them are clubs out of the 52, and then you have to again reduce your fraction, which reduces to 1/4. Next, let's take a look at how many cards are face cards. So we want to get all the face cards, whether it's a jack, queen, or king, and whether, you know, regardless of what suit it is, we want all the face cards. So we have 3 times 4, because there's 3 in each suit. 3 times 4, which is 12. So there are 12 face cards out of the deck of 52. And then again, you have to reduce your fraction, and that reduces to 3/13. Lastly, what is the probability of pulling one card from the deck and getting a red card? Well, as I stated at the beginning, half of the cards are red. So if we have 52 in the deck, then you have a total of 26 out of the 52 that are red cards. That's half of the deck, and that already tells you that, yes, of course, when you reduce that fraction, it's going to reduce to 1/2. So anytime you want to pull a red card out of the deck, or black for that matter, it's always going to be a 50-50 chance of pulling a red or black card, because half of the deck consists of red and half of the deck consists of black. Okay? And again, theoretical probability just means that the possible outcomes based on the math of what is there, based on that formula of the event, the probability of the event that's in the numerator, over the bottom, which is your total possible outcomes. In this case, our deck, we have 52 cards, so the bottom would be 52. As you notice with all of these calculated outcomes, and the top is always your event, the event that is you're speaking of, that you want to know that can happen, okay? The probability of that event. Now let's go to experimental probability. Now, experimental probability, unlike theoretical probability, where it is based on a math and a formula, experimental probability is found by performing repeated trials and observations. In other words, you're actually doing the experiment over and over again to determine the probability that it can occur. So let's do an example. Well, first of all, let's go over the formula. The formula would be the event on top, whatever the event, however many times it occurred, and on bottom would be the total number of times that you did the experiment. Okay, so if E is an event that happened when an experiment was performed, then the empirical or the experimental probability of the event is given by the formula top, the number of times the event occurred, over the bottom, the total number of times the experiment was performed. Let's do an example and it'll make much more sense. So after receiving complaints, a skateboard manufacturer inspected 1,000 skateboards at random. The manufacturer found no defects in 992 skateboards. What is the probability that a skateboard selected at random had no defects? Write the probability as a percent. So we're asked to write our answer as a percent. So what we need to do is we're going to first get our answer in fraction form. Then we're going to divide top divided by the bottom to get it in decimal form. And then afterwards move it 2 places to the right to turn it into a percent. So let's begin first by writing it in fraction form. So if you'll notice, on top will be the total number of times the event occurred, and we want to know the event when it was no defects. So when they did the inspection, they found that there were 992 that had no defects. So 992 would be on top. The bottom is the total number of times the experiment was performed. We can see here that the manufacturer inspected 1,000 at random. So it was done 1,000 times. That would go on the bottom, the experiment. So what you have then, your fraction is 992 over 1,000. So go ahead and get your calculators out and do top divided by the bottom. And what you're going to get is your decimal. After you get your decimal, go ahead and move the decimal place 2 places to the right. And what you'll find then is that the probability that a skateboard selected at random had no defects would be 99.2%. Table 3 below shows the results of an experiment with pea plants conducted by a famous scientist by the name of Gregor Mendel, who is considered the father of genetics. He did a study on pea plants, which help us to understand how genetics and traits from our parents are passed down from generation to generation. And so this cross-producing offspring, the chart shows you how all the pairing of these combinations were formed. So the capital R here is, the capitals are referred to as the dominant genes, and then the lowercase are the recessive. So if you see right below the table, it gives you a legend there of what these symbols stands for. So when you have 2 dominant, it's going to produce red. Remember the lowercase is the recessive, so if you have a dominant and a lower, that's going to produce pink. So red and red gives you red. Red and R is white, is going to give you pink. And 2 whites is going to give you white. If you look at the chart here, you see here the dominant red with another dominant red will produce red. It's sort of like a cross offspring there. And then the dominant red with the recessive white will give you pink, and so forth. Again, crossing those will give you the pink, and then R and R is going to give you the white offspring there. But anyway, of all the possibilities that you have here, our sample space would include 4 different offsprings there. So of that, in this particular problem, we are asked to find the probability that 3rd generation offspring would produce a red flower. So the red would be the ones that have the 2 capital R, the 2 dominant genes, and of this sample space that we see, there's only 1 out of the 4 that are red, would exhibit red. And so the probability is 1/4. Now we can write that as a decimal by simply top divided by the bottom. That's going to give you 0.25. And then if you want to turn it to a percent, all you have to do is move the decimal places 2 places over, and that will give you 25%. Let's do one more. So determine the probability that a third generation offspring would exhibit a pink flower. With the pink flower, if we look again underneath here of the legend there, that's going to be where you see the capital R and the lowercase r. So the dominant and the recessive will give you the pink. And of that, in the sample space, we have 2 that has the uppercase and the lowercase, the dominant and recessive gene, which produces the pink. And so we would say that it would be 2 out of the 4. And when we reduce that fraction, we'll get 1/2. And to turn that into a decimal, top divided by the bottom, that's going to give you 0.50. You can move that 2 places to the right, which means there's a 50% chance of that probability that it would exhibit a pink flower. Cystic fibrosis is one of the most common inherited diseases in the U.S. Approximately 1 of every 2,000 Caucasian births and about 1 of every 250,000 non-Caucasian births inherit the disease. Find the empirical probability that cystic fibrosis will occur in a randomly selected infant birth among U.S. Caucasians. Round your answer to 4 decimal places. So we want to know the probability that cystic fibrosis or the randomly selected infant would probably have the disease. So we were, based on the studies that they've conducted of cystic fibrosis, for the Caucasians or whites, they have found that 1 of every 2,000 are born with this disease. So that is going to be our probability. So on the fraction on top, you're going to have a 1. On the bottom, you'll have the 2,000. So let's put this in terms of a number of percentage-wise. So all we need to do is top divided by the bottom. That's going to give it to us in decimal form. And then when we move our decimal places 2 places to the right, we will get the percentage. And yes, notice that it is a small percentage, but yes, there is a likelihood that it could happen. Now let's see what that looks like, that percentage in terms of non-Caucasian birth. So if we were to randomly select a non-Caucasian or non-white infant, we were given that statistic is 1 out of every 250,000. So on top you would have your 1, on bottom 250,000. So to turn that into a percent, top divided by the bottom, that's going to give it to you in decimal form. Move your decimal places 2 places to the right, and you get your percentage. And as you can see, the percentage is a lot smaller for non-Caucasian birth than it is for Caucasian birth in the U.S. Let's say there were 150,000 North Americans Caucasian birth that were randomly selected. Amongst those, how many occurrences of cystic fibrosis would you expect? Now, we were already given the statistics for that ethnic group, that the occurrences of, or the probability of getting cystic fibrosis was 0.05%. So all we need to do in order to find out how many of that population of 150,000 would we expect to have cystic fibrosis? So what we want to know then is what is 0.05% of 150,000? Now we can use direct translation to solve that, and that is just simply multiplying, because here notice you're going to multiply 0.05% times 150,000. So to multiply that, you can just move the decimal places 2 places to the left to write 0.05%, write it as a decimal. Again, move it 2 places to the left, write it as a decimal, and then go ahead and multiply it with 150,000. So get your calculators out and go ahead and multiply that so that you can tell me how many of the 150,000 Caucasian births would you expect to have cystic fibrosis, or there's a probability that that number of birth could have it. So what number did you get? Well, you should have gotten 75 if you did it correct. So again, we wanted to know what was 0.05% of 150,000, and that was 75. So we can expect 75 of those Caucasian births could have cystic fibrosis. Sickle cell anemia occurs in about 1 of every 500 black baby births and 1 of every 160,000 non-black baby births. So find the empirical probability, and again, this is experimental probability, that sickle cell anemia will occur in a randomly selected black baby. Round to 3 decimal places. All right, so here, after several studies, numerous studies, they concluded that 1 out of every 500 black babies birthed could have sickle cell, and then 1 of every 160,000 for non-black babies birthed. So we want to know what is that probability. So for the black baby, on top, our fraction would be 1. On bottom, it would be the 500. And again, to get the percentage, all we have to do is top divided by the bottom. That's going to give it to us in decimal. We can move our decimal places 2 places over to the right and turn it to a percent. And that's 0.2% chance that the baby will have the sickle cell. All right, now let's see what it looks like for a non-black baby. The statistics for that, remember we were given, was 1 out of every 160,000. So on top of the fraction would be a 1, and on the bottom 160,000. To turn that into a percent, top divided by the bottom, that's going to give it to you in the decimal form. Move 2 places to the right to turn it to a percent. And as you can see that other ethnic groups other than black have a much lower chance of getting the disease than a black baby. Okay? So if we were to randomly select 800 births of black babies from various hospitals, about how many occurrences of sickle cell anemia would you expect out of that 80,000? So based on our statistics of this occurring among black babies, it's 1, recall, 1 out of every 500, which is 0.2%. We already got that percentage from the previous problem. So all we need to do is, we want to know, again, what is 0.2% of 80,000. So again, you can change 0.2% to a decimal by moving 2 places to the left, and then multiply that number with 80,000. So go ahead and get your calculators out so you can tell me how many black babies would you expect out of that number to have sickle cell. Okay, so what did you get? All right, so the number you should have gotten there is 160 births, black babies birthed there. Good. You're doing great. Let's keep moving on. Next, we want to talk about odds. Many people fear flying, but did you know that the odds in favor of dying in a airplane crash are much lower than in a car? Based on the studies, the odds in favor of dying in a plane crash are 1 to 2,067,000. The odds in favor of dying in a car accident are 1 to 7,700. So notice here that yes, your odds of dying in a car accident are much greater than it would if in a plane crash. In the study of probability, odds are used to describe the chance of an event occurring. It is usually expressed as ratios in one of two ways. So you either have the odds in favor of an event, in other words, the odds that the event will occur, or the odds against that event, the odds that that event will not occur. So to find the odds in favor of something that will happen, all you have to do is on your fraction, you would have, if you want to find the odds in favor of something happen, on top you would write the odds of it happening, over the bottom the odds that it's not happening. And if you want to know the odds against something happening, it would be the odds that it will not happen on top over the fact that it will. So it's going to be always opposites with these odds. So although odds are defined as fraction, we usually state them by reducing the fraction to the simplest term and reading them as a ratio. So unlike the probability odds, we usually read them as a ratio. So again, to find the odds in favor of an event happening, it is the probability of on top that it will occur over the probability that it will not occur. So here's an example. Mrs. Jones' group of kindergarten children includes 9 girls and 7 boys. If she randomly selects one child to be first in line, find the odds in favor of selecting a girl. So what we want to know is in favor of selecting a girl. So the probability as far as your fraction on top would be of selecting a girl over the bottom of not selecting a girl. So let's take a look at of selecting a girl. So we have how many girls? Yes, we have 9 girls. So you're going to have 9 on top. And how many are not girls? 7, because 7 are boys. And that's going to go on bottom. Now, that is your fraction, and again, odds are most commonly read as a ratio. So it would be read as the odds in favor of selecting a girl is 9 to 7. Okay, so now let's calculate the odds against an event happening. And so that probability, your fraction on top, is the probability that the event will not occur over the probability that the event will occur. So on the top, again, is will not occur, and on bottom that it will occur. Let's do an example. If Angela randomly selects or chooses a ball from this jar, find the odds against selecting a yellow. So in your fraction on top, you're going to have not selecting a yellow, and on the bottom you're going to have the probability of selecting a yellow. So let's go ahead and get our top number, not yellow. Let's go ahead and count how many balls in the jar that are not yellow. So that's 1, 2, 3, 4, 5, 6 are not yellow. So 6 will be on top. And then for yellow, we have 1, 2, 3, 4, and 5 that are yellow. And so that's going to leave us with 6/5. So we would say that the odds against selecting a yellow ball is 6 to 5. Converting between odds and probability. The odds of students completing a college algebra class at Palmdale College are 16 to 9. What is the probability that a student will complete the class? So to find the probability, or to convert from probability to odds, here's the formula. And that is just simply the odds in favor of an event are A to B. Then A would be on top, and that would be your first ratio that you were given. In this case, it would be the 16. And then on the bottom, you're both A and B, you're going to add them together. In other words, it gives you the total. So the total will be under the bottom. Okay? So there were 16 students that had favorable outcomes. So the ratio was 16 to 9. Remember, odds are will over will not. So 16 are your will, and 9 are your will not that will complete the class. In terms of if you add those two together, that's going to give you 25. There was a total of 25 students in all in the class. So to change this odds that we were given into a probability, all you have to do is, again, use that formula of the part of the event of those that will. We want to know will. There were 16 that will complete it. Over the bottom is your total. To get your total, you would take the wills and the will nots and add them together, which gives you 16 over 25. Top divided by the bottom, that's going to give it to you in percent form. Decimal form. And then from there, to put it in percent form, move 2 to the right. So again, top divided by the bottom gives it to you in decimal form. To get it in percent, move 2 to the right, which means that there is a 64% chance that a student will complete the class. So now we've turned that odds of 6 to 9 into a probability. The probability is a 64% chance of completing the class. In a certain sweepstake that was giving away a car, your odds of winning were 1 to 99,999. So what is the probability that you will win? So here we're given the odds, and the odds that you will win is 1. 1 means the fact you will win. That you probably won't win will be 99,999. Now, to turn all of this odds into a probability, it is simply placing the fact that you will win on top, and that's that 1. And on the bottom, the fact that you will win plus the fact that you won't win, that's the total. You would write that down below. So when we do that, it's going to look like so. And so all we need to do is add the bottom, and that's going to give us there 1 out of 100,000 chance that you will win the sweepstakes. Now let's go ahead and turn that into a probability by turning it into a decimal and then into a percent. So decimal top divided by the bottom, that's going to give it to you as a decimal. Move over 2 places to the right, and so your chances or percentage of you winning that sweepstakes would be 0.001% chance that you'll win that sweepstakes. There's a 30% chance of rain tomorrow. Give this information in terms of odds. So here we're given the probability that there's 30% chance that it's going to rain. We want to write it as an odds, okay, as a ratio. So all we need to do, step 1, is to turn the 30% into a decimal by moving 2 places to the left, and that's going to give you 0.30. Next, we want to turn it into a fraction. To turn it in a fraction, you just simply look at the place value. Remember, on this side of the decimal is the THS family. So this is tenths, and then over 1 more is hundredths place. So we're going to write it as 30 over 100, because you would read that as 30 hundredths. So here we have this is the chance that it will rain. They said 30%, so 30 would be will rain. Your total is your 100. So in order to find the odds, remember odds is always going to be your 2 opposites. So in this case, because you want to find the chances that it will, so it's going to be the will over will not. We already have the will. The will is 30. So to find the will not, the chances that it's not going to rain, all we need to do is subtract from the total the fact that it will rain, and then we'll get the will not. And so again, that's 100. Take away that 30% chance that it will rain, and what you're left with is the 70 that it will not rain. So now your odds, placing will over will not, 30% that it will, 70% that it won't, reduce your fraction, so we can cancel a 10, a common factor there, and that's going to leave us with 3/7. So then our ratio would be 3 to 7, and there you have it. We started out with a probability of 30%, and we converted it to odds, which is a 3 to 7 odds. Here we're given a probability of 0.37 and asked to convert it to odds. So here is the event that it will happen. So this is your will. And again, just like we did in the previous problem, we can change this decimal to a fraction that's tenths, hundredths, so that would be 3,700, so 37 over 100. So 37 is your will, your 100 is your total. So to find your will not, all you have to do is subtract that 37 will from your total, and you'll have the will not. So when you subtract the 37 from there, you're going to get 37 over 63, because now 63 is your will not. And those are your odds. You have now converted it from probability to odds. To write it as a ratio, it would be 37 to 63 odds in favor of the event happening. In the previous problem, we were given the probability of an event occurring was 0.37, and we were asked to find the probability in favor of the event. And to turn it into odds, and recall it was 37 over 63. Well, in this example, we're going to do the very opposite, which is the odds against the event happening. And lucky for us, we don't need to do any math whatsoever, any calculations, because if the odds in favor, remember, is will over will not. So to find against is will not over will. All you have to do is simply flip the fraction and put will not on top over will on bottom. So the odds against a 37 would be 63 over 37, and to read it as an odds, it would be 63 to 37, and there you have it.